Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we got the Willsenton R300 connected up to the Analog Discovery 2 with the freeware audio analyzer suite that I use to test my gear with. This is a cool little setup. It's an oscilloscope and a signal generator in a box, interfaces with a computer, and then the software this guy's made really makes this a joy to work with. But anyway, in the link below if you think you might want something like this. But now it's time to go test this amp. So now we got the R300 hooked up to my Tektronix 2235 analog scope, my Tenma analog signal generator. We have the input set at 246 volts peak to peak, which is right around 2 volts RMS, maybe a breath more. And let's pull up the R8 and see what we've got. And as you can see right there, we've got clipping. And it's not perfectly symmetrical. It starts clipping on the negative side first, but it's not totally wonky. Let's get this right on the verge of clipping. And this is set on 5 volts per division, so that's 5, 10, 15, 17 volts peak to peak into an 8 ohm load, which gives us 4.5 watts of output before the amp starts clipping, which is just a little over half of what they advertise this amplifier being, which is an 8-watt amplifier, which honestly I thought was stretching it for a 300B amp. I know my DIY one makes about 7 watts, but this one's about 2/3 or less of what I got out of my DIY one, which was a budget 300 build. No high-end parts. Was using just Edcore iron, nothing fancy. So, not super impressed with what I'm seeing. And again, this is another one of these amps that this is probably a 3rd volume, if that, probably about 10 o'clock. And it's into clipping with a 2 volt RMS input. So real quick, let's do the how much input signal does it take to make this amp clip. And it's right there. And then we'll switch this to basically got just a little less than 1 volt peak to peak. Go put on a 0.5 volt and you can see it's actually about probably 0.8 volts peak to peak drives the amp to clipping, which honestly with modern sources is a pretty hot input. But all these China amps seem to be built that way with a super hot input. So let's go back to running this thing with a 2 volt RMS input, and it gets us back to our 17 volts peak to peak. And let's see what the square wave looks like. Now this is a 1K signal. So there's our, and again this top trace is the signal generator so we can compare them. And look at that hot mess. I don't know what's going on there. This is one of the nastiest looking square wave signals I've ever seen. It's got this weird, let me see if I can. It's got this weird like double dip thing going on here on the front. I have no idea what's making it do that. Like I said, that's one of the ugliest 1K square waves, which is actually the easiest square wave for a tube amplifier to reproduce. Let's drop down to 100 hertz, and again, my signal generator struggles to do a really good 100 hertz square wave, but a little bit of a slope on it, but not extreme, which is showing that it's probably got fairly decent low frequency response, which is a plus. And again, you can see the input signal's got a little bit of slope to it. That's my signal generator struggling a little bit at 100 hertz, but you can see there's more slope here than is in the input signal, but not by a whole lot. So pretty decent results for 100 hertz. Let's switch this thing now to 10K. So here's our 10K sine wave coming in, and let's see what the output from the R8 looks like. That is insanely bad. I have no idea what would make an amp do something that horrible unless somehow the feedback loop is just totally wonked out, or just totally garbage output transformers. Honestly, I've never seen anything like that come out of a tube amp. At least none of mine have ever done that. There might have been some ringing on the front end, but this is like ring. Guys, that's just pathetic. I have no idea what's going on. I'm going to flip it over to the other channel and just make sure that's not a channel specific thing that's happening. And there's the other channel. That is one hot mess of a square wave. And again, that's what the 10K square wave looks like coming out of this amp. So let's toss this thing on the audio analyzer suite and see what it shows. But guys, this is not looking good. Okay, so let's look at how this amp reads on the Analog Discovery 2. And the first thing people are going to want to see is THD versus power. We are measuring this like I normally measure amps. We're measuring just the THD. We're measuring it at 1000 hertz up to 10 watts, 8 ohm load. And here's what we got. Down here at very low volume levels, got about 0.5% of distortion. Then it dips down here once you get up to about 1/4 of a watt or so. You're still below 0.5% of distortion. Starts creeping up here, and you notice there's a difference between the two channels. And when I see that, that's normally an indication of a tube. And so we are going to swap the output tubes here in a minute and see if the higher distortion follows the output tube. And I've seen that with lower end 300B tubes. I've played with those before in my own 300B amp and found that there is a distortion difference between tubes. So anyway, as we follow this guy up, here's 1 watt, that magic first watt that everybody says is the most important. And as you can see, we've got 0.4% distortion on one channel and 0.7 on the other. And so then we have the rule that some people use by saying, how much power does it make at 1% distortion? That's what I want to know. And the amp is advertised as being 8 watts at 1% distortion. Well, I'm measuring, and this is just THD. This isn't THD plus noise. On one channel, when you hit 1% distortion, it's making 1.75 watts. And then on the other channel, when it hits 1% distortion, it's making 3 watts. Now, more of what I look at is what is it doing at 2% distortion. So there's 4 watts on one channel, and you got 5 watts on the other. And where it's claiming it makes 8 watts, that's at 6% distortion. So, is this really an 8 watt amp? I'll let you be the judge of that. I would say that it's more around a 4 to 5 watt amp at listenable distortion levels, which isn't horrible for a 300B amp. It's better than the A50, but it's not as good as my DIY 300B amp. So then we're going to come over here and look at the THD versus frequency. And this is a fairly common thing to see higher distortion levels at low frequencies. And at our 1000 hertz, this is at 1 watt. So remember, over here at 1 watt, we're seeing between 0.4 and 0.7% distortion. But if you look at it via frequency, yeah, at 1K it's doing that. There's our 0.3, our 0.4 and 0.7% distortions. But down here at 20 hertz, we got 5% distortion on one channel and 1.6 on the other. Pretty big jump difference between the two. And even down here at 40 hertz, which is where you'll hear stuff. There's music down here. We got 1.5 and 0.7. This is showing me that while the output transformers aren't horrible, they are not top shelf items either. This distortion at low frequencies is a sign of output transformers that are either undersized or they're just not super high quality. And then there's this weird little anomaly, and I've tried running this test at different power levels, and all of them had this strange dip here, right around 8K. It dips down real low and jumps back up. I've never seen an amp do that. So I'm not sure exactly what's going on there. And I swapped the output tubes and I'm letting them warm up. And they are settling in with the same bias after swapping them. So it's not a mismatched set of tubes, which is a good thing. So then we come up here to the frequency response and take a look at it. And again, I tried running this at different power levels here, and I kept getting this same shape curve. Now there is a little roll off on the bottom end, which isn't super extreme. Got maybe 3 dB roll off here at 20 hertz, and then it comes up here, flattens out pretty quickly. Let's see, there's 30 hertz, pretty much just flattened out by then. Again, a little bit of anomaly between the two channels, but nothing severe. But we start rolling off on the top end. We got about 2 dBs there, and then it just drops. And I have no idea what's causing this. Again, I've done multiple sweeps at different power levels, and all of them have this big dip here at like 15K. It's just a weird anomaly. I've never seen a frequency response curve in all the amps I've built and tested. Never seen this before. And I believe that they have some negative feedback in this amp, which is strange for a 300B amp, to have negative feedback. Normally they don't have any. I've never needed any with my 300B amps I've worked on, and the A50 didn't have any. I'm not sure why this one needs negative feedback, and honestly it didn't really help the distortion levels a whole lot, as you saw on the power versus THD. So we let the amp warm up here, and remember the blue channel was higher than the red channel in distortion. I've swapped the two output tubes, and let's do another pull here and see if the distortion swaps and the red one ends up on top. Now that's interesting that swapping the two output tubes, that they're now fairly even, and they're both biased the same. I didn't touch the bias adjusting screws, and the meter shows them still in the middle, but it basically kind of balanced out the two. So maybe one of these preamp tubes plays better with that output tube, or not sure what's going on here, but it definitely improved. It made one channel worse and it made one channel better. So now on both channels at 2% distortion, we're making 5 watts. So swapping the output tubes, not sure what that did, why it would affect that, but probably just a wonky set of China tubes. So let's hook the scope up and take a look at that. Okay, so I decided to pop a pair of electroharmonic 300B tubes in to see if that was impacting the power output. So here we go at 1K, and we are getting more power. Pull this down, get it just shy of clipping. We've got about 21 volts peak to peak now. 5, 10, 15, 20, which comes out to right at 7 watts per channel. So replacing the output tubes gained us, looks like a couple of watts of power, and that's always a good thing. It gives us some headroom. So that lets you know that the tubes this thing comes with are pretty junky. And I did replace the 6S and 7s with some Sylvanias and put an RCA 6SL7 new old stock to get these results. So basically, to get anywhere near the power this thing is rated at, you have to throw away all the tubes it comes with, which on a 300B amp, they are not cheap to replace. So the next thing I want to go ahead and look at is see if this did anything for our square wave, and didn't change it a bit. It still looks horrible. And let's crank it up to 10K and see what that square wave looks like now. No change. That's a absolutely horrible 10K square wave. I have no idea what's going on. But anyway, we were going to figure this out. So let's move on to our next test. So after seeing the scope results, I decided to come back and do one more round on the Analog Discovery 2 with the Electroharmonics tubes in. And we've got both these tubes biased up right where they tell you to have them biased, dead center on the meter, which I'm not sure what that equates to in milliamps. None of the instructions tell you or anything, so we're starting off with just here's what they tell you to do. And so here's the square wave on the Analog Discovery 2. which matches exactly what we saw on the analog scope. And then here is the 10K one. Same wonky, crazy stuff that we saw on the analog scope. And after seeing this, we may be able to possibly skip dealing with the analog scope, although it does give us a clipping point, which I'll have to experiment and see if that can be found here in the Analog Discovery 2 stuff. But let's go back over here to the THD versus frequency. Again, we got 10 watts as our max, got 8 ohm load. It's going to stop the test at 10% distortion. And let's see what kind of results we get with the Electro-Harmonix 300B tubes versus the ones the amp comes with. So this first pull is THD versus noise, which we didn't do last time. And this is looking quite ugly. You can see at low volume levels, there's clearly a ton of noise in this amp. But changing the tubes definitely increased the power output. Let's do just the THD this time, like we did on the first run, and see what that looks like. This is looking very similar to what the original one looked like. Again, this is just the total harmonic distortion. We're not testing for extraneous noise in this pull. So it goes past a 0.5% of distortion at 1 watt. We come in here, we're calling 2% distortion our limit. We're just under 7 watts is what we saw as the clipping point on the scope as well. On this other channel, it's 2% at 5.5 watts. And then the left channel is at 7 watts at 2%. And it's not unusual for a tube amp to have a little difference between left and right channel as far as the distortion. In here we're seeing about a 0.5% distortion difference between the two channels, which is not unusual for a tube amp. And even, down in this range, there's about 0.4% distortion difference. You can see these kind of railroad track each other right through here, which again, not totally unusual to see that, but just like we showed in the last test, if you're talking about reasonable distortion numbers, this is a 6 watt amp. And then their claim is that it does this at 1% distortion, and if we average the two channels with upgraded tubes at 1% distortion, it's a little over 3 watts. So this is just what it is, guys. Let's go ahead too and check the frequency response one more time with different tubes and see if that crazy thing at just over 10K hertz is still there. But given what we saw on the 10 hertz square wave, I'm pretty sure it's still going to be there. And there it is. Look at this massive dip here. That's like 15 decibels of roll off. Have no idea what's causing that. So anyway, I think this is a good place to wrap up this video. I know it's been going kind of long, but I wanted to give it every benefit of the doubt, putting in some known good tubes. And while tube rolling definitely improved the power output, it did not fix all the sins this amp has. And I have no idea what's causing all these problems over 10K. So anyway, this is like a good place to wrap up this video. Well, as you can see, those results are far from ideal. I was really hoping that this amp maybe just had some issues with the power supply, dealing with the issue with these things blowing rectifier tubes like I've been seeing online, kind of figuring out what they're doing with this soft start board, possibly try to figure out a better solution with a thermistor or even changing the type of rectifier tubes to an indirectly heated one. But then on top of that, we've got other performance problems. I've never seen a square wave that bad. Hopefully it's got something to do with the way they implemented the feedback loop, or something else that they dropped the ball on that's going to be easy to fix, but I don't know until I dive in here. This looks like it's another mess like the 850 was. I don't know what's up with these 300B China amps and this crazy stuff that they do. Anyway, you saw the difference in the performance between this, even with good tubes in it, and my DIY 300B amp that was built as a budget one with basically low-end iron. The only thing fancy at all in it was some Mundorf caps. The rest of it was just generic stuff from Mauser, and it definitely destroys this amp as far as performance. And so here we are once again with another made in China product that's got issues. So anyway, hopefully this isn't too involved. At least from a glance inside, it doesn't need all the resistors replaced like the R8 did. And so maybe, who knows? Let's just keep our fingers crossed that this doesn't turn into a real nightmare. But anyway, hope you're enjoying this content. If you are, and you're interested to see what we do with this amp, please subscribe, please like the video, and thanks again to you Patreon folks for your support, also people that make donations, and to the folks that send gear like this amp that this guy drop shipped, so that we've got stuff to review, fix, modify, for content for the channel for you guys to enjoy. So until the next video, have a nice day.